Hello, today I will show you how to use data transfer modifier to make a perfect tile set with aligned normals, vertex colors. UVs will be done by hand. An example of Morrowind Hlaalu wall set, as it's the only piece I have left in my overall Hlaalu vanilla mesh fixes. But before that, after previous videos, you asked for some examples how it looks in game. So here we have my old play install without any fixes. Like, it has old optimization patch with some mesh fixes, but not the one I did last time. On the wall here, for example, we have not aligned normals, resulting in different shading on that straight piece and that up piece. Similar thing on the corner and gate, much less visible, but slight shading difference also, besides not perfectly aligned UVs. That manor house shows the best and the most visible normal display. We'll start by applying all transforms. Merging all meshes together, merging vertices. And this time, as we require aligned normals, we will convert mesh to quads, but first I'll show why. By default, imported mesh normals on opposite sides are not perfectly aligned. Even if we throw weighted normals modifier on top and apply it, it's better, but still not aligned, as that face and that face weight differently. Some balance between lengths of those edges. I'm not sure of the math behind it all in Blender, but if we convert it to quads, let's check if it worked everywhere. Yes, rather simple mesh. And now put weighted normals in quad mode. Everything is perfectly aligned. If it's some complex mesh, you can't just convert to quads without losing data. You could create a proxy mesh that will work as a template for your tile set, be it straight corridor or 4x intersection, and keep it as a source for your data transfer. But in this case, a simple straight wall will do. Next, let's check if it's perfectly aligned to grid. 1.8, 1.8. Here's not smooth for some reason. Single vertex. I have no idea why, but sometimes weighted normals do not smooth it properly, like if those edges were split for some reason. Now it's not symmetrical, so it's also wrong. Let's try again. Should work in theory. Apply. Yeah, worked this time. No idea why not the first time. So we have good normals, tiling geometry as alignment to grid goes. And now let's check vertex color. Looks good by eye. And check UVs. I'll try to do it on a single screen. Not mirror. Align to X, align to X, 1, 0. This side is flipped, so I'll mirror them by X, so they are always aligned in the same order. It's good, good, good. So UVs are fine. That piece can work as our template. We need to create a vertex group containing border vertices. In this case it could be a single group for both sides, and then we would have to assign it twice for some more complex shapes, but I'll show it with two groups. Name one of them X plus and other one X minus. This one is X plus, this one will be X minus. X plus, X minus. Now select border vertices, apply it into group. This will be X plus. This one should be Y plus, but we don't have such on our template, so we'll use wrong. Move new group X minus. Check them. Okay. Now that's data transfer modifier. Source will be our template. Vertex group will be X plus for now, and select face coordinate data. We need custom normals and shift click to select multiple vertex color. What we have by default, nearest corner to best matching first normal. Should work in this case. I used it before for other sets. As we can see, something is certainly wrong in there. Let's check on matcap overlay. We must align our template, so let's select both, enable grid snap, make sure that grid is set to 1.28, move it so it aligns with our target. I will copy it to the source to keep it as backup. Apply. Before I do it for the other side, I will show you why. As you can see, vertex normals are perfectly aligned to YZ plane after that data transfer. Before, when they are just weighted, they're aligned to those edges just coming from the curve, and they wouldn't tile with a straight piece or another corner arc. Let's repeat it for the other side. Let's rotate our template, not -90. Place is so it overlaps. That's our -x side, and we have our -x group here. They overlap properly. Copy our data transfer here and just switch vertex group to -x. Apply. And the result is perfectly perpendicular to the grid vertex normal. Our vertex color also got adjusted if that was needed at all. Likely not, but better be sure than sorry. Here those lowest vertices were outside of the template, but they're properly approximated from those that would still fit. It might look a bit off, but the geometry is the same. Like it goes visibly up on the last segment, while it should flatten right after that, as there is no another segment that's flat in that section. It goes into another flat one. Here we are back in editor after exporting all the meshes. First, let's show the tower. All those triangles are gone, no matter the side. Stretching on going up walls piece is still there, but not seams on tops. Curved piece have a seam on one end as it's in an opposite axis than here. No seam there. Not seams in the pieces going up either. Here's something wrong with that gate. Let's check what it is. Hlaalu gate 1. That's tab. It will be much less stretched when scaled to 2. Same thing on those edges. Let's check other gates. Yeah, if that piece would be rotated, there wouldn't be a seam. Looks good to me. Something wrong with normals. Could it be that bending on such small distance distorts them already on the joint? Okay, should be enough. Source minus X, face corner data, color and custom normal. Selected. Still looks wrong on that side. much better on the side, but not exactly on the top this time. Yeah, tiles perfectly this way. So that was just UV sim. But that's all I see, so I'll call it a day and just fix those few places off screen, then upload it to Morrowind optimization patch and set up pull request so it could be reviewed by my team.